Imagine a user trying to confirm a financial transaction on your app, but they can't move focus into the confirmation modal using their keyboard. Or worse, a screen reader user is never told that a critical dialog has even appeared. Inaccessible modals don't just frustrate users, they can block them entirely, create compliance risks, and harm your product's reputation. Today, you'll learn how to build accessible modals in React from scratch without relying on external UI libraries. You'll discover how to make your modals fully navigable with the keyboard, manage focus so users never get lost or stuck, and ensure screen readers announce your dialogues clearly and accurately. We'll cover the technical essentials, like ARIA roles, focus trapping, keyboard event handling, and restoring focus after close, so you can implement modals that everyone can use, regardless of how they navigate. You'll come away with a toolkit to boost your app's usability, meet accessibility standards, and create a truly inclusive experience. In real-world terms, this means smoother login flows, safer confirmations for destructive actions, and better onboarding for all your users. If you're serious about building robust, user-friendly web apps, this is knowledge you can't afford to skip. Make sure to subscribe for more high-quality, practical tutorials that keep you ahead of the curve. Because accessible design isn't just best practice, it's the future of web development. Imagine the structure of a modal dialog in a web application as a secure vault in a bank. Only authorized personnel should get in, and everyone else must stay out until the vault is closed. In the context of accessibility, this translates to managing keyboard navigation and focus so that, when a modal appears, users can only interact with the modal's content. No matter how many times the user presses Tab or Shift plus Tab, their focus never escapes the modal, just as you can't walk out of a vault through a wall. This principle is known as focus trapping. When a modal is opened, the application must programmatically shift focus inside the modal, typically to the first interactive element like an input or button. Think of this as a security guard guiding you into the vault and closing the door behind you. As you move through the vault, you can't accidentally exit until the guard opens the door again. Similarly, pressing Tab should cycle through all interactive elements within the modal, looping from the last back to the first, and vice versa with Shift plus Tab. This is achieved by identifying all focusable elements in the modal and intercepting Tab key events to wrap focus. When the modal is closed, focus should be restored to the element that opened it, creating a seamless, predictable experience. Without this system, users relying on keyboards or assistive technologies might become lost, unable to interact with the main application or the modal effectively. This vault analogy underscores the importance of strict focus boundaries for accessibility and user confidence. Consider the way a theater spotlight draws the audience's attention to a particular actor on stage, while everything else on set fades into darkness. In accessible modal design, ARIA roles and attributes serve as this spotlight for users of assistive technology, especially those using screen readers. Assigning role dialog or role alert dialog to the modal container tells the screen reader that a dialog has appeared, much like announcing a new scene in a play. ARIA modal sought true further clarifies that interaction is restricted to this dialog, preventing background content from being read or interacted with, similar to how the theater set becomes off-limits when the spotlight is on the main actor. The ARIA labeled by and ARIA described by attributes act as a script, ensuring the dialog's title and description are announced clearly, setting context and intention for the modal's purpose. If these attributes are missing or incorrectly implemented, users may miss critical information or not realize a modal has appeared at all, akin to an audience missing a key line in the play. By thoughtfully applying ARIA roles and attributes, developers ensure that the appearance of a modal is unambiguous, context-rich, and navigable for all users, regardless of their method of interaction. This focused spotlight effect is essential not just for clarity, but also for compliance with accessibility standards and the creation of inclusive digital experiences. This is the main application entry demonstrating how to use the accessible modal component in a React app. It includes an open modal button, ensures correct focus management, and provides both keyboard and screen reader accessibility. This file provides the core implementation of the accessible modal component. It handles ARIA roles, focus trapping, keyboard event handling, including tab and escape, overlay click to close, and restores focus after closing. All accessibility requirements are addressed without external UI libraries. This CSS file defines the visual presentation of the modal and overlay. It ensures the modal is centered, overlays the background, and provides focus visibility. The close button is styled and positioned for accessibility. This is the main entry point which renders the app component into the root DOM node. It uses React 18's Create Root API for concurrent rendering support. This HTML template provides the root mounting point for the React app. It sets up a basic document structure with language, charset, and viewport for responsive design. This test file validates the modal's focus trapping and keyboard accessibility features using React Testing Library and Jest. It ensures that focus does not escape the modal and that pressing escape closes it. This package.json defines the project dependencies, including React, React DOM, and testing utilities. It also lists scripts for starting the app and running tests. The application loads, revealing several accessible modal demo options. Scrolling down, all the demo sections become visible. After exploring the interface, the view returns to the top for the demonstrations. First, the profile form modal is opened. The modal appears centered, overlaying the background and capturing keyboard focus. Inside, a form requests a name and email. The name field is filled with Ada Lovelace, and the email field with adaanalytical.engine. The keyboard tab key is pressed, moving focus through each field in sequence, demonstrating the focus trap. Focus cycles forward from input to input, then to the action buttons. Using Shift plus Tab cycles focus backward through the fields, confirming that focus remains contained within the modal. The Cancel button is clicked, closing the modal and restoring focus to the main interface. Next, the Stacked Alert Modals demo is activated. The first modal overlays the app, displaying a destructive action confirmation. Within this modal, clicking Delete Anyway opens a second, nested modal. In the inner modal, the input labeled Type Delete to confirm is filled with Delete, and the modal continues to trap focus for keyboard navigation. Pressing the Escape key closes the inner modal, returning to the outer modal, which still traps focus. The outer modal is closed by clicking the Cancel button, returning to the main app interface. The Image Lightbox modal is then opened, displaying a large image in a modal overlay. Pressing Tab moves focus to the Close Lightbox button, and pressing Enter activates it, closing the lightbox and restoring focus to the application. The Custom Initial Focus modal is opened next, and focus is set to a specified element inside the modal. Pressing Tab moves focus to a secondary button, and Shift plus Tab cycles focus back, again demonstrating contained keyboard navigation. Pressing Escape closes the modal, returning focus to the main application. Finally, after closing the last modal, pressing Tab confirms that keyboard navigation is restored to the main application, and background content is once again interactive. Throughout each scenario, modals trap focus, restore it upon close, prevent interaction with background elements while open, and support both keyboard and mouse interactions for complete accessibility. By now, you've seen exactly how to craft an accessible, keyboard-navigable modal in React without relying on any external UI libraries. You've learned not just the step-by-step implementation, but also why each accessibility best practice matters, from focus trapping and ARIA roles to robust keyboard handling and screen reader support. Integrating these principles into your projects means everyone can interact with your app smoothly, regardless of their device or abilities, and you're building products that meet both user needs and legal standards. If you want to keep your skills sharp and stay ahead with hands-on, real-world React and accessibility patterns, make sure to subscribe. Every tutorial here is packed with actionable techniques you can use immediately, so you can ship better apps, faster, and with total confidence. Ready for more practical guides that actually level up your workflow? Hit subscribe and let's keep building accessible, high-impact interfaces together.